Chapter 6 is the beginning of our work in trigonometry. So we're going to start with some quick review of trig functions here. 6 sections I'm interested in. So we're going to begin with section 6.1, angles and arc lengths. Now, if you all recall, an angle is simply two rays that emanate from a common point, called it a vertex, that creates an angle. So I mentioned about a ray. A ray is a half line that has a starting point, and then it goes in a direction, right? It extends indefinitely in one direction. So this is what the ray is. You're looking at a half line. And suppose I have another ray that emanates from the same common point, again the vertex, call it O, V, whatever. The two form what we call an angle. Now the notation for angles, by the way, there are several ways you can indicate angles. So for instance, if I call these points, if I mark these points A and B on each of these rays, OA and OB, so I can write using angle notation, angle A followed by the vertex and then the other point on the other ray. So that's one way to denote angles. I'm sure you're familiar with that notation. Or we can simply give names to angles. So for instance, this is angle theta. And some people actually do this. Angle O, just reference to the vertex, which is O. We tend to use the most common letters used later on in most of math and science courses are alpha, beta, theta, phi, gamma, and so on. We usually use Greek alphabet to name or label angles. So I tend to use theta more often than others. Okay, now the angles are usually what we call in standard position. So before I get to the standard position, let's actually draw some angles. So this would be one ray. This would be the initial, let's call it the initial side of the angle. And then here's the second ray. And we're going to call that the terminal side. The idea here is that the angle starts with the initial and then progressively works towards the terminal side. So this would be the measure of angle that goes like that. Okay, and that's the initial side again, and we have the terminal side of the angle. An angle that goes in a counterclockwise position, we're going to agree by convention to call that a positive angle. So remember, counterclockwise is positive. If the angle goes in a clockwise direction, so let's say here's my initial side, there's my terminal side. Goes in this direction, then that would be a negative angle. In this case, theta is less than 0. So clockwise, negative, counterclockwise, positive. It is possible for the angles to revolve more than 360 degrees before they stop on the terminal side. So let's say I have my initial side here, and then I have my terminal side. Let's start here. The angle revolves, goes around once, and it goes a little bit further and it stops. Okay, and let me do this. And there you have it. And then this is where the terminal side is. You see that? That's the final resting place for the angle. And this would be an angle here whose measure is more than 360 degrees, but we'll talk about that in just a moment. But in either case, the measure of angle is a real number, by the way. An angle could be positive, negative, 0, and so on. So in general, theta, the angle theta, is a real number. And again, as a real number, that means it could be 0, positive, or negative. Now, an angle in standard position for us, let's agree, the standard position for us, that means if you look at the xy coordinate system, here's x, there's y, the initial side lies on the x-axis. Okay, so this would be the initial side. And then the terminal side, wherever that might be, could be here, 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 anywhere. You can rotate several times and end up in some place. Okay, therefore that's what the initial side would be. And then terminal side, I'm just going to mark it in the first quadrant, and there it is. This is again the terminal side. All right, now how do we measure angles? Well, there are three ways we can measure angles. Two, I'm sure everybody's familiar with. A third one, not many people, especially the younger generation, knows about. So here are the measures of the angles. Okay, we can measure angles. Let me write that. Measures of angles. The most common measures are degrees, which we can relate to very easily. Degrees. The other one is radians, which is usually used in applications in calculus and sciences quite often. And then the third one is gradient measure, or simply grad, or let's call it gradient. This is the one that not many people know about. Okay, so let's start with the degree. In degree measures, the circle is divided into 360 equal parts. Okay, so if you break this into 360 equal parts, and there you go, that would be 1 part, so this would be 1 degree. Remember, the full circle is 360 degrees, therefore 1 degree would be 1 360th of a complete rotation around the circle. That's what a degree is. So I'm just going to write 1 degree equal 1 360th of a complete revolution around the circle. Therefore, 1 revolution, we can convert revolutions now to degrees. 1 revolution is equal to 360 degrees. And this is the most common measure of angles that just about everybody knows about. Okay, now when it comes to angles themselves, special angles, we talk about right angles. A right angle is an angle whose measure is 90 degrees. Oh, I mentioned I did something, but I didn't tell you about. I used this degree symbol here and here. In fact, that's what that is. It's a null sign. That's what that is, a null symbol or sign. That just means degrees. That's all that is. Okay, so a right angle measures 90 degrees. That's theta. 90 degrees is a right angle, and the right angle could look something like this. There you have it. 2 rays and the angle between them. If you put the square, that means it's a right angle. Or we could have a straight angle. Angle could be straight. Straight angles, those are the ones where angle is 180 degrees. And the reason, rightly so, here's your initial side. The terminal side is to the left of this point O, so there's a measure of the angle theta. It's a straight angle. Okay, the angles could be acute. Acute angles are those that are between 0 and 90 degrees, exclusive of both. Okay, if it's exactly 90, then it will become a right angle. And then we have angles that are obtuse. Obtuse angles are those that exceed 180 degrees. So they're beyond straight. And they stop just shy of 360 degrees. Okay, and there you have it. Just to label the angles here. Now, once we've talked about degree measure, let's talk about the other popular form of the angle is the radian measure. Okay, with radian measure, radians. With that one, we actually, to talk about radians, let's talk about the arc length of a circle. Okay, so I put that one on hold here. Let's talk about the arc length. The arc here would be a curve, the arc length of a circle. So suppose I have some circle here. Okay, well, let me draw my circle a little better. there we go. Suppose I have that circle there. The arc length of a circle, this is, let's say, the central angle theta that subtends the arc of a circle of that length. There you go. That is what the arc length is called. This is an arc of a circle. Here's a measure of central angle theta of some radius r. Now the arc length, usually we use s for that. Okay, and that's what the arc length is. Now the full circumference of a circle measures 2 pi r, right? Remember the formula for circumference is 2 pi r? Well, from this, we can actually come up with a formula for radian measures. Now to do that, we also have a formula for the arc length. S is equal to r theta. Okay, so the arc length is given by r times theta. Now, in order, because the length is a real number, so theta here, theta must be a real number. So that you multiply by a real number, the radius, and you get a real number, a value, tangible value for the arc length. Now, this formula S equals r theta. For the full circumference, S is equal to C. So we can say that 2 pi r is equal to r theta, correct? Cancel the r's because they're non-zero. Divide by both sides by r is positive. Therefore, theta is equal to 2 pi. So what we're saying is this. The measure of the central angle theta for the full revolution of a circle, 2 pi, which is 1 revolution, is equal to 2 pi. And this is what's called the radian measure. Okay, 2 pi radian. So think of radian as synonymous with real numbers. Okay. Therefore, I'm going to write that one revolution around the circle is equivalent to 2 pi radians. Okay. And remember, one revolution is also equal to 360 degrees. So from this, we can get a formula, or call it conversion factor. Think of it, a formula, but it's really a conversion factor. A conversion factor between degrees and radians. So we can say that if 2 pi is equal to 360 degrees, then divide by 2, and pi is 180 degrees. So this is the conversion factor between radians and degrees. Now, if we divide both sides here by 180, then I can say that 1 degree, dividing both sides by 180. So I can say 1 degree is equal to pi over 180 radians. Okay, and I can likewise say that 1 radian is equal to 180 divided by pi. The reciprocal of that will convert it into degrees now. So for example, suppose I want to convert 30 degrees to radians. Okay, well, this is the conversion formula between them. So I'm going to go 30 times pi over 180. And that would be 6. So it's going to be pi over 6 radians. Okay. And we can convert radians to degrees. So for example, let's say I want to convert pi over 4 to degrees. So I'm going to do that. Pi over 4, well, to convert to degrees, I'm going to have to do conversion, 180 over pi. So I'm going to go pi over 4 times 180 divided by pi. Pi is crossed out. 180 by 4 is 45 degrees. Okay, and so there you go. That's the conversion between the two. All right, and the third one I mentioned that nobody anymore knows about is gradient or grads. Grad or gradient measure. Now with gradient, it's interesting. You divide the circle into 400 equal parts. So it's easier to think about a half circle. 180 degrees would equal to 200 grads. Okay, so from this relationship, we can get the conversion factor. Therefore, 1 grad is equal to 9/10 of a degree, or 0.9. Okay, or 1 degree is equal to 10/9 of a gradient or grad. Again, the grad is kind of a forgotten measure of angles, but I just mentioned it just so it doesn't completely die out. At least maybe you at the beginning of a generation who will recall or remember grads now. Okay, and let's finish this work with the area of a sector of a circle. The area of a sector of circle. A sector is a portion, right? So suppose I have a circle like that, and I have this sector. Remember, the arc length was S. We already talked about it. The measure of central angle is theta, and the radius is r. Now, the formula for the area of a sector is going to be 1/2 r squared theta. And remember, theta must be in radians, because anytime your measures are real numbers, then you have to use radian measures for the angle. Okay, so for example, to show you something, if we don't convert to radians, suppose the measure of central angle is 45 degrees, and the radius of a circle is simply 4 inches, which isn't much. It's shorter than the palm of your hand. Okay, and suppose we want to find the area of a sector of a circle with those specifications. So if I just simply go to the formula, I have 1/2 r squared, and theta is 45 squared. Notice I'm doing what I'm not supposed to. I'm actually using the degree measure, ignoring it that is simply in terms of revolution around the circle and not a real number. And if I carry on the calculation, I get 16,200 square inches. I'm just going to put, wow. Okay, that's a lot of area, isn't it? For simply the palm of your hand almost. So that just tells me that my answer is not sensible, right? And the reason is because I did not convert theta into radians. So if we do this now correctly, the area is going to be 1/2 r squared. Now theta was 45 degrees, right? I have to convert it into radians. So remember, anytime in any course, math, sciences going forward from here on, anytime you have a formula that involves an angle theta, you must convert the angle into radians. Otherwise, you cannot use that formula. Very simple. And when you work this, we get 4 squared is 16, 16 halves, 4,580. That's 4 times pi over 4, and 4 times 2 is 8. 16 by 8 is 2, and now the answer is very sensible. 2 pi square inches. All right, so just wanted to again quickly review measure of angles with you. I'm sure all of you, nothing new here that you probably didn't recall from your high school days, but there you have it. So we're going to keep this video short, sweet, short, and that will be the end of this video.